Hello, my name is John Froats. I'm an associate professor and nuclear engineer in residence here at University of Ontario Institute of Technology in Oshawa, Ontario. I've been with the university now about a year and a half, joined after a lengthy career in industry. I was chief nuclear engineer for OPG, ran a large project portfolio of about $500 million a year, and have run companies and hired and supervised up to 1,600 engineers in my career. Reason I came to UOIT is a great place to contribute to the youth of the industry and to the developing of the young minds who will lead the industry through the next several decades. Here at UOIT, we use a variety of learning techniques, which I hope in the next few minutes to be able to give you a little tour around some of the things that we do to try to make the learning experience here at UOIT unique and different. I have the great privilege to work with a faculty that brings a large and diverse background to the learning situation. Strengths from many aspects of industry. In my particular background, I have the opportunity to teach courses on nuclear plant safety design, nuclear plant operation, and I run an undergraduate thesis program here at the university. We have the view here at UOIT that learning is more than just learning the nuts and bolts of equipment and the mathematics and science of the technology. It really takes an understanding of the how the plant works, as well as understanding how to be a nuclear professional. So learning has to go beyond the simple learning the fundamentals, and particularly in third and fourth year, we blend that learning of how to be a nuclear professional in with the technology. So to give you the kind of example, in the undergraduate thesis project that we run, students learn not only a technical subject, but they learn things like project management, how to interface with customer groups, the kind of way to make sure that you're predictable in the outcomes of any endeavor. Those are things that are directly applicable in the workplace. UOIT was founded on that premise. The nuclear faculty here is focused on preparing young men and women to enter the nuclear power plant business and associated supply businesses and bring the best minds to bear on the problems of tomorrow. Today I'd like to show you a few of the tools that we use in the educational setting. Today we're in the simulation lab at UOIT. It's on the 4th floor of the ERC building. And as you'll see in the next few minutes, it's a journey from today looking forward to tomorrow and bringing all kinds of new technology to the hands of the students to prepare them even better for tomorrow. In our nuclear program, we make heavy use of simulation, and here we are in the simulation lab. In the screen behind me, you'll see a simulation projection of a 900 megawatt CANDU nuclear power plant. On the screen, this gives us an overview of the power plant. You can see we're running at 100% full power. The screen gives us a block model of the turbine generator, the feed water condensate system, and you can see it has capability in real time to trend. When I first started to use this tool, I was actually quite amazed. The simulation tool comes with the textbook for the program. It's able to be run on the student's laptop, and as you'll see in a few minutes, it gives a pretty good image of a power plant with considerable fidelity of how the plants actually respond in real time. You can take different slices of the plant with different screens on this simulator. As we see here, we're moving to a view of the heat transport feed and bleed and pressure control system. All our CANDOs, whether they're the 600 megawatt variety, 900 megawatt variety, they're all fundamentally the same kind of design at the science fundamentals. And then it's the design application and the scaling of size that makes them different. So here we can see a couple of the key vessels, the pressurizer that controls heat transport pressure during normal operation, a bleed condenser, which is used to prepare the heavy water for the cleanup circuit in the plants. And you can see the trending in real time of a number of the different parameters. You can see our real-time simulation updates, and as I say, the fidelity of this is pretty spectacular for a small simulation. Just in a moment here, I'll put in a plant upset, so you have a sense of the kind of response you can see in this type of learning tool. So if you think about a progression for a nuclear engineer to be excellent at what they do, the learning journey begins in the first couple of years of the nuclear engineering program to really understand the science fundamentals, the electrical circuits, the thermodynamics around the plant, the fluid hydraulics, to be able to understand cause and effect. When we deliver the plant operation program in either third or fourth year, it's really targeted at building from that platform of science fundamentals, giving the students some exposure to real-life plant systems, and then use the simulator as a tool to integrate and reinforce that knowledge. So we use it both in the lecture mode, so as we're talking today, I'm giving a little bit of a very quick overview of this simulator, but we also use it as part of the portfolio for the students to do homework assignments, to learn dynamically how the power plant runs and how things respond to failures in the power plant. The CANDO 900 megawatt simulation allows you to input malfunctions out of a selected menu to give the student the ability to see the dynamic behavior of the power plant. You can see our pick list here. We're going to in a moment show you what the plant looks like after a trip of the turbine generator. In nuclear jargon, what a turbine trip means is that the electrical generation or output of the turbine is interrupted for some reason. It could be a problem with grid distribution, or it could be a problem on the turbine generator set. Once you insert the malfunction, you can queue up a little bit of a time delay so that you have the opportunity to actually focus on the full spectrum of response. When I was an emergency response director for OPG in 2003, when we had the big blackout, we saw transients in some of our power plants that was very much like what you'll see here on the CANDO 9 simulation. This gives the student an excellent opportunity to look at cause and effect in the power plant and look at the dynamic behavior of the power plant rather than a simple static exercise. We can see here our turbines just tripped, the generator breakers have opened, and you can see our control systems responding on the trend graphs much the way the real-life power plant does. As I say, I was amazed at how much fidelity there is with this type of simulation compared to the actual response in power plants. You can see here our pressurizer level and set point changing, boiler levels responding. You can see the reactor power has decreased. We just got an alarm of steam generator high level, and you can see our turbine output went from 100% down to 0. At any point, the student can move from run mode to freeze mode, and that will lock the transient so that we can focus on a part of the of the scenario to understand with depth. So we use this routinely in the classroom and in assignment work so that students on their own can exercise their classroom learning and their textbook learning and complement it with simulation. Hope this gives you a sense of the kind of thing that we have here at UOIT in the nuclear program at the undergraduate level. And in a moment I'd like to show you the simulation from the Darlington power plant and explain how we are starting to blend that into the learning opportunities at UOIT. About a year and a half ago, UOIT started an initiative in partnership with Ontario Power Generation, OPG, to look at a training delivery called Advanced Operations Overview for Managers. The program started several years ago, internal to OPG, and is a learning package of about a 5-month duration to provide managers with a real good understanding of power plant operation.
I'm Dean Townsend. Currently I'm the Senior Design Manager at Darlington Design Authority. I act in the role of the Design Authority. Recently, in February of 2012, I was fortunate enough to be able to participate in the AOM course at UOIT, the Advanced Operations Overview for Managers.
Hi, my name's Tom Switkovich. I'm the Manager of Plant Design at the Darlington Nuclear Station. This past year, I got an opportunity to spend some time at UOIT with the AOM Advanced Operations Overview for Managers training program here.
The people that were in the class were senior managers with many years of experience, so we found that it was a very good interaction and synergy among the class members when we were studying, and when in our after hours discussions we utilized each other's specialties and different skills that were brought to the table. Some people were more theoretical, some people had better organizational skills, some people had good plant experience, and we found that the interactions and cooperation among the team helped us absorb the material and be more effective and make the training more effective.
I think it was especially useful for me because I was able to bring some of my own experience here, and again, a lot of the material that we learned here was not just learning material for the first time, but also taking existing material, knowledge that I had and experiences that I had, and dovetailing them together in a way that enhanced the overall understanding of the plant and of the processes.
The simulator is an excellent tool. As I said previously, it was probably the most valuable piece I picked up out of the course, use of simulator, and it really ingrains the training in your mind, allows you to quickly refresh. I think as a training tool for undergraduates, it would have to be focused and used heavily in conjunction with the training, but I think it would be an excellent tool.
The partnership with OPG enabled the educational opportunity to happen here in the UOIT simulation lab. So we saw a few moments ago the CANDO 900 simulation that we use for undergraduate education, and here in the simulation lab we're looking at the simulation of the Darlington nuclear power plant. Here behind me on the screen is the simulated view of the control room for the power plant. You can see the display panels in the backdrop, different parts of the plant, reactors, boilers, heat transport. Very much looks and has the feel of the real control room. The simulation allows us to go into the different areas, to pick different parts of the power plant, to blow it up so that we can zoom in and then learn about a particular slice of the power plant. Just like the undergraduate simulator, we're able to put all kinds of different malfunctions in. So this allows the student to again begin with science fundamentals, the platforms of how physical things work, and then progress into how it's brought together to operate and control a real nuclear power plant. So as we move along the screen, if I were to go here and zoom into one of the panels, you come over to a shot that looks like this in the middle screen. It gives us a more detailed look at the power plant. We can see our turbine generator at the top and the connection out to the grid. You can see our plant's making 873.4 megawatts electric, and we can follow the energy flow right back in through the various parts of the plants, the steam generators, and of course the nuclear engine that powers the plant. Gives us all kinds of opportunities for malfunction. You see a freeze opportunity, the same as the undergraduate simulation. This simulation offers an additional number of features. You can see we can display multiple screens at the same time. So I can be observing what it looks like in the control room, looking what it looks like at a systems or overview level, and then I can move right along to the third panel of display, and I can see at a system level what's happening. So here I can move from place to place in power plant operation with much more fluidity than I can with the more simple simulator that we're using for our undergraduate education. And students in the Advanced Operation Overview for Managers program become quite conversant with the operation of the simulator as well as operation of the power plant. Again, I'm just amazed if you look at how simulation has progressed over the years. I was a licensed shift manager at the Pickering facility just as the training simulators were coming into play. Today, the nuclear operator or shift manager can use this tool quite effectively, even away from the plant, as we are here today at the university, gives the opportunity to actually interface with all aspects of power plant operation. This does give us a tremendous amount of flexibility to move back and forth. We could take an upset as we did on the undergraduate simulation and show the plant dynamics. It's an amazing tool, but for purposes of our time together today, I'd like to move on to give you a glimpse of what the future is. This gives us the ability for some interaction through the computer. The next step is touchscreen capability, interaction with panels, so it looks, feels, and is just like in the control rooms of the power plant. Let's go have a look at what's on the drawing boards for coursework in the not too distant future. So here we are with a look at tomorrow in the simulation lab at UOIT. Behind me you'll see a simulated control panel for the Darlington power plant that gives that interactive feel with the touchscreen capability. I can move the controls, I can manipulate the power plant just like I can in the real thing. This gives us the next step in that realism in education, to be able to get students to have not only the sense of the science fundamentals, the power plant systems and integration, but the real feel for interface with the control from the control room. We're about a year away from introducing this into our educational syllabus, but I think you'll see that it really is a glimpse at tomorrow, a tremendous opportunity. It takes me back to the days when I was a shift manager. It has that real feel of a real can-do power plant control room.